Welcome to the third video on the F1 Evaluation Platform. It's basically a demonstration of an implementation of using Great Cow Basic. Great Cow Basic is available on SourceForge, and it's a development language for the microprocessor set. So what is this thing we're going to be looking at? It's actually a board that's operational. I'll flick out of that. It's actually operating here. We can see it sitting here waiting for me to play with it in a moment, and we'll go through some of the functions in a minute. What it's actually based on is a fully featured chip, and it's a demonstration board from Microchip itself. I'll move that out of the way, and it's actually a microprocessor. It's actually a PIC16 F1937, and it includes a whole series of information, the standard for a chip. What we're going to be using is quite a lot of the memory. No EEPROM in this particular program. I2C. We can use the UARTs. We're using a couple of the timers. We're using 32 megahertz internal processor, low power oscillators, etc., and the controller, LCD controller. As you can see on the board here, that this is the chip here, and this is the LCD, and the LCD controllers on board inside the chip. The other things we're going to be looking at is an MCP temperature controller sensor. There is obviously a connector into the PIC kit. I use PIC kit 3, and there's a serial PIC kit, and we'll be using that in a moment. I'll show you that as well. There's a button, a potentiometer, a couple of LEDs, 4 LEDs. There's actually a motor connector as well. There's that digital CD we saw before, etc. And there's actually a current monitoring connector as well. So if we look at those on the PCB themselves. So let's have a look. Here's the temperature sensor. It's this device here. And the debugger header is obviously there. This is the serial header. And this is the button here. This is the white button there. This is the potentiometer. This is my second board because the previous board, the potentiometer broke, but it's been replaced. There's some LEDs down here. There's a 20-bit header down here for a motor expansion, an LCD. And that must be the same 20-pin connector, and there's a current monitoring sensor here. So I'm powering this not from the PIC kit. I've actually got a 3.5 volt power supply just hooked into this connector here. I can turn that on and off as I see fit. So what have we got? What we've got is default firmware. That default firmware supplied with the board blinks the LEDs. It measures the ambient temperature. It runs the motor. If there is no motor attached, it does try to do that. It displays the time, temperature, pot position, motor, RPM, etc. And there's a user interface with the pot. So what I'm going to do, I'm actually going to do something that I don't normally do. We're going to actually load in that stock. We'll load in that stock code. Okay. I'm actually loading that in now. And here's the stock code. Powered up, 6 o'clock. Time now is a bit later than that. But essentially what we've got is a pot here. And this, I'll use a pencil. I'll use my finger. We use a pot, and that changes the interface. What we're seeing here is the time set to 6 o'clock. We're looking at the temperature, current temperature. And we're looking at the pot position and RPM. And let's just have a look at the clock. Initially the clock here, we can see it says RC here for clock. It's got a little icon here that's flashing away. It's got a diode, and it says A for AM. If I hold down the button for 1 second, we can see it change the time. And I can change the time from 6 o'clock to 7:05. I'll try and get 7:05 in one hit. Oh, into 8:05, there you go. And it's just a case of holding down the button. This is the stock, and now the clock is set to 10:05. As you can see, it's still in the morning. If I roll that over, you'll see that A disappear into midday, and it will go to 1200 hours at 1200 hours. That will go. Now we're at 1 p.m. Second thing it does is measure the ambient temperature, set by the K here. There's a little K. And the third operation is the RPM of the pot. Now you can see it changing values here, but we're getting no feedback on the LEDs, because that LED that's actually lit there is we haven't got any RPM coming from, so we've got no feedback. So what I did something pretty similar using Great Cow Basic. So what I did Great Cow is link the LCDs using the pot value. Measure the ambient temperature. I've actually got retention of the maximum and minimum ambient temperatures. Display the time, temperature, pot position on the LCD, very similar. User interface again with pot, and communicate via the serial port to the PC. So what we'll do now is we'll have a look at that code. And my current stock code is version 982, and it's a version that I'm going to load up now, and you'll see that come up. And it looks pretty similar now. Well, what we saw initially was the 982 pop up. That pops up just to tell me that what particular version number of code is in there. Same function in terms of the time. So I'll hold that down. We can now try and set that to 705, which is what I was trying to do before. I did it wrong again. Bit tired tonight. 805 will do. And you can see that I've got the A here, the flashing LED. I've also got real-time clock here, and you can just about make it out sometimes down there. There's something flashing, and that is flashing because every time it loops through, I can see it. There's another little icon there flashing away. And so what we've got is the same function in terms of time. We're using the crystal clock to get the 1 second pulses. We're counting pulses, and I'll explain in a minute how that function works. Second one is temperature. Temperature's risen, I think, and you can see that we've got this flashing down here just to say it's working still. We've got another display in here to say it's on temperature in Kelvin for temperature. But what we've now got is maximum and minimum, so we can see that this is flashing between the M to the left of the K and the ohm to the right of the K, and that's signifying maximum minimums that we've had. And if I hold it down long enough, you'll actually clear that down. So what I'm going to do now is hold it down, and then we'll see it flash up as 0, and that just clears out the maximum minimums. And we're doing that from a button press function that's got a number of states. And there we go, 0. Now we've got new maximum minimums, and you can see we've got new maximum and minimums. What we now got also is a pot controller. I can now control the pot. Though you can just make it out in the on the screen here with the LEDs actually rising and falling. There we go. Now what it's actually doing, unlike the other code, it's doing a lot of this stuff in the background. So whereas before it was all blocking, this is non-blocking. So currently it's 806. It is still taking pot readings. It's merely taking pot readings where the previous version wasn't, and it's actually taking temperatures. It's taking maximum, minimum temperature readings. I can put my finger on that. I put my finger on it for a few seconds. Take it off. Go back to the temperature. We can see it's 28 point drop in temperature. So what was the maximum? There we go. So it was taking that temperature in the background. So I've got the processor actually now running in the background as well, and the code does that. So what we've got is blinking LEDs in relationship to the pot that's going on. That's real time as well. Measuring ambient temperatures, as I said, maximum mins, display the values, etc. So what we've got in terms of Great Cow functions, we've got obviously the I2C driver, which is the bog standard I2C driver from the standard Great Cow implementation, and that's driving the MCP 9800 temperature controller. That's fully blocking, so once it makes a call into that, it doesn't do much more, but it's actually only polling it every second, so it's not overly complicated. Real-time driver. There's a real-time clock. I developed that. It's pretty simple, but basically it counts time since 6 o'clock this morning. It will roll round, but I just set it to 6 o'clock as an arbitrary point. It keeps time internally every second and just ticks away quite merrily. It seems very stable. And there's an LCD driver, and that LCD driver contains all the code necessary to drive the screen, that LCD display. So let's have a quick look at Great Cow Basic itself. We can leave that screen up there. What we'll do is we'll actually set this to auto import. So what it's going to do every time I make a change to the code shortly, it will update it. There we go. I'm just going to look at that particular copy of the code. So basically what we've got is we've got a couple of external files to be included, and they're just the inputs and output device drivers, and we'll look at those in a moment, because I've got all the inputs in the input file, all the outputs on the serial, and the output devices. And currently there's nothing connected on the serial. Standard setup, etc. Standard inputs and outputs. What I actually do is to control all my outputs to my serial port, I have a define, which I'm actually going to change now. So I'm actually going to turn on the RS-232, and I'll bring up a terminal in a moment. So I'll just pop that screen in here so we can see it. I'll compile that up. Whilst it's doing that, I'll bring up PuTTY. Now that is not the board that's doing that. This is a quite large set of assemblies that it's actually running with. I just need to connect up the serial port. I'll do that in a moment. So what I've actually got is a serial ports connected to there we go. Serial ports connected to a MAX 232. What I've got here is a cable. It's my RS-232 connector, and I'm just going to connect that in, and I'll move that terminal window up slightly so we can see what's going on. This is not practiced, so I'm just going to insert that in there, and we can see already that it's actually doing some stuff. So if I just turn off everything, I've got a switch here on my power supply, turn everything off. I'll just clear that down. We can see it coming from the top. So here we go. I'll just reset the terminal, turn the power on, and now we can see we've actually got some code running. So basically what we're seeing now is maximum, minimum temperatures, etc. They're all being set at the moment. I'm going to pull that across. I'll reset it once more, only because then we can see that display. Reset the terminal. Reset the terminal. Turn power on. And as it's going through now, it's got the serial code. We'll see it actually update values, and it's all done through ANSI control. Pretty simple. These are all functions that are included. So we can see 4 seconds in, we got a maximum temperature, and at 9 seconds in. So these are the times. This is the value of the current time. This is the values that it's actually retaining, and up here we can see the state of the button. So if I actually push the button down, we get a button down here. I let it go, and then we can see that it's now updated. It's doing what it says on the screen. If you look here, it's actually got the pot value coming in. So it's actually pulling it across so we can communicate bidirectionally. Now we do all that. It's pretty simple stuff actually. What I've actually got is I've written some ANSI control screens, and this is essentially controlling the screen. So when we saw it come up before, it's basically these control strings that says clear the screen, position the screen, and output some information using the Great Cow standard functions. Initializing up the LCD and moving through to setting up the actual code. Now the code itself is pretty simple. It just tests for some buttons up and buttons down, and it does things based upon the buttons up and buttons down. There is a function that says that the button can be up, the button can be down, the button can be released, and I just test for those. So I go button up, button down, button released, and so you say, well, we've only got 2 states. We haven't. We've got 4 states of a button, and the function I've written or ported actually and adapted holds all that. The timing is all in here as well, all included. Pretty simple stuff. The output devices. It's quite interesting to look at. Is the I set up the LCD and the actual function of displaying the values on the screen is pretty fast. Essentially, I transfer everything to a binary coded decimal. So the number 732 is held in the got the bytes of memory, and I strip those down and just send them directly down to the ports. It's not nice. It's not pretty, but it's extremely fast. I've left my old method in, so if anyone wants to have a look how to do it slowly and use all the aliases, that's in there as well. I'm essentially writing directly to the ports at high speed. It gets me in and out of that function extremely rapidly, which is quite important. The other drivers that were necessary were to be written let me just say, the LCD driver. The MCP 9800 had to be written, the switch had to be written, and other key functions that make this thing operate. So I'm just going to turn off all this serial, just revert that back. I'll press F6 and we'll see it do its funky stuff. So I'm actually using the IDE that's been put together up on GS Tools. It's extremely useful. It's made my life a lot easier doing this development. What we're now seeing is it's assembling the code up. It's now compiled that, and it's now been loaded into the PIC. There we go, 982. So you might say, well, how do I put that 982 on the screen, for instance? That's pretty simple, because I've got these standard functions now, and it says here, display int 982 on the screen and turn on a decimal point set below that. So here we have display a value. Let's put the decimal point on. There's 3 decimal points, and then wait a second. And that's essentially, and that's how we do things. It's all adaptations of that one function, to be quite frank. A couple of interrupts running, and the rest of it is just logic ported in from the other piece of code. Let me have a look at the input. So all the inputs are the MCPs. I didn't mention those. They're now all documented, so you can just do a get temperature. It actually handles, which the original one doesn't. This actually handles negative values. It will actually handle negative values in terms of temperature, where the stock code does not. This does support negative codes in terms of temperatures. And finally, the other piece is the output serials, and this is essentially the code for the serial. So if you want to position something on the terminal, if you want to clear a line, if you want to erase the screen, that's all included in here. You've also got some other functions. If you want to show a binary value, then it will do that as well. Let me just clear that down. That just resets that. I'll just reset the whole thing. We should see no output from there because we turned that off. 982. So for those who want a quick demonstration of what we can do, I'll add a couple lines of code in. So let's just make a quick piece of code change just to demonstrate some of the functions. So we've got, as I was demonstrating before, we've got a way of displaying integers, and that's an integer 982, and that's the version number. We saw that pop up before. And then we have a weight. Now I've added in just a quick clear the LCD down, and I've added in this function here, which is a little piece of code, which is essentially determining an integer, and then putting real numbers into the display. So it's minus 199 to 199, and that's the maximum that this display can do. And whilst that's compiling up, I'll just talk you through that. So what I've got is a function that's called display real and display int. They handle one holds real numbers, one holds negative numbers. You could call either, they do the same effectively, but one does not handle negatives. And it will then display it on the screen. So if we go over to the program, let's have a quick look on the, here we go, here's the actual board, it's just been programmed, 982, and there we have, just going through the full range of numbers, high speed. It's amazing how long 1 millisecond is. We'll just that's not 200 milliseconds to do that task, but it's quite fast. So I'll just take that code out and we'll have go back into the main video. So I'm just going to revert the code. I'll close that down, open it up. Now I use I do use SVN here. I use SVN into my server. It's not a server, it's actually just a D-Link device that's running SVN. It's been extremely useful over the last few years just to keep track of code, etc. Keep a copy of everything I do. I can do fault versions, etc. I am not a programmer by trade, but it's something I do as a rather big hobby. Building robots. Got the competitions there in the bag. And now we can see that we're back on the original code. I didn't see it boot, so I'll just check the boot number. 982. The pot's full on, for those who can see it. That's good. Well, and that's all I wanted to show, that what we've got is a set of functions that can be reused. Those functions are the ICT, the MC, the temperature, the real-time clock, the LCD driver, etc. They're all sort of working now and pretty stable. Couple of issues that have been resolved as part of this by the development team. I am so grateful to them for their patience, because this has been an interesting journey. So with that, I'll say thank you to everybody, and that's the end of what I wanted to show you with respect to the F1 Evaluation Platform for Great Cow Basic.